to go on topic called logarithm. We want to do it in such a way that the teacher teaching at in various school can teach better. The learner learning logarithm can find it friendly. Also, the parent can help their word at home to understand logarithm. So first and foremost, we want to see the standard form of a number. 1. We want to see how we can write a number in standard form. 37.43. When a standard form of a number is a number that can be in form of 1 point or 2 point or 3 point or 4 point or 5 point or 6 point or 7 point or 8 point or 9 point. It cannot be 0 point. This is wrong. It must be a digit point. Then looking at this, we are having 2-digit point. So it means that the decimal point will be shifted backward once. So that will be 3.743 times 10. It must be times 10 raised to power. The number of times we shift the decimal point backward once. Number 2, where you have 493.7. So what do? We shift the decimal point backward because this 493, if it comes here, it becomes 49 points. If it comes here, it becomes 4 points. So it will now be 4.937 times 10 raised to power 2 because we shifted it backward twice. If we have 8.73, so what do we have in this sense? The decimal point will not be shifted at all. Hence, it will be 8.73 times 10 raised to power 0 because we do not shift the decimal point. Then number 4, when you have 0.103, what do we do to this one? The decimal point will have to be shifted forward because 0 point, we say it cannot be 0 point. So the decimal point will have to be shifted forward 1.03 times 10 raised to power minus 1. Number 5, when we now have 0.00009. When we have this, the decimal point will have to be shifted 0, 1, 2, 3, 4, 5. 9.0. When we look at this, some will say 9 times 10 raised to, no, it should be 9.0 times 10 raised to power how many times? 1, 2, 3, 4, 5 raised to power minus 5. Take note, when the decimal point is being shifted backward, it will be positive, the number of times you have shifted it. And when it is shifting forward, it will be negative, the number of times you have shifted it. And when you neither shift backward or forward, it will be times 10 raised to power 0. That is the standard form. But bringing the standard form to logarithm, let us now see the exercise. Now, when we talk about logarithm, what is logarithm? Logarithm of a number is the power or index by which a certain number or base must be raised. In a simple language, we can say logarithm means power or index or exponent of another base. So we refer to the power. So what we are now saying is this. If we have 8 is 2 raised to power 3. We know that 8 in index form is 2 raised to power 3. So what is log 8? The question is, to what base we want to put 8? If we decide to put it in base 2, it means that log 8 in base 2 is 3. Look at it, it is the power. So log means power of a number when it is expressed in a certain base. So when you have log 64, the question is of what base? If it is base 2, what will be the power? 64 in base 2 means 2 raised to power 6. Therefore, this one will now be 6. The power of 2, when 64 is expressed in base 2, is 6. We are talking about the power. Log 64, if it is expressed in base 4, it will be equals to 3. So therefore, 4 raised to power 3 equals to 64. That is the base. When it now comes to 4-figure table, using 4-figure table, all number is expressed to base 10 in 4-figure table. So what we pick in the 4-figure table is the power of 10. What we pick in the 4-figure table is the power of 10. Take for instance, log 2. If it is in base 10, if the base is not written, it's in base 10. If you check the 4-figure table is 0.3010. That is 2 equals to 10 raised to power 0.3010. You may confirm this from your your calculator. 10 raised to power 0.3010. Likewise, log 3 base 10. What you will check your 4-figure table, it will be 30 under 0. It means that it is 0.4771. That is 3 equals to 10 raised to power 0.4771. Let us now come to the basic thing now. How do we solve problem using 4-figure table? We look at it in this order. Number 1, characteristics. You are the one to decide to decide the characteristics. How do we decide the characteristics? Characteristics will not be checked in the 4-figure table. How? Characteristics of a number is the power of 10 when the number is expressed in standard form. That is why to teach logarithm, especially using 4-figure table, you must first of all teach standard form, and that is why we teach standard form. So, and I want teachers to follow this method with the students, though it is not the usual way, but we can introduce an idea that will help the student, that will help them to remember either in basics, SS1 and SS2, which is basic 10 and basic 11. So we have number, standard form, characteristic, then mantissa. mantissa. How do we check this? Number 1, 78.47. We want to see how we determine the characteristics. 78.47 means that we write in standard form first, times 10 raised to power 1. The decimal point shifted backward once. Therefore, characteristics is the power of 10. 1 point. I have said characteristics is the power of 10. 1 point. Can we see? We pick this, the 1 here. Then number 2, when you look at 301.3, 301.3, what do we do? The decimal point will be shifted backward twice to have 3 points. That will be 3.013 times 10 raised to power 2. That is our characteristics. Will also be what? Power of 10, which is equals to 2 points. Let's look at 8.732. Number 3. What is 8.732? We have 8.732 is already written in standard form, but for it to be proper in standard form, it must be times 10 raised to power 0 because it is not shifted. Therefore, the power of 10, which is 2, which is 0, it will not be 0 points. Number 4, 0.508. How do we write this one in standard form? That would be, we shift decimal point forward once, 5.08 times 10 raised to power minus 1. At this juncture, we will now write the power when it is negative as bar 1. The negative will be written on top, not touching the number. Then we call it bar 1. Especially those of you in basic 11 and SS2 or SS2, you will be introduced to a number less than 1. Number 5, 0.0007. This will be 7 point, because when you look at it, 1, 2, 3, 4, 0. If you look at it, 7.0. Do not write 7. 7.0 in standard form times 10 raised to power how many times? 4 times. 1, 2, 3, 4. This will now be bar 4 point. Let us take note of this. Then we shall now look at the mantissa. What is mantissa? Mantissa. Mantissa are decimal parts. So the power of 10 extracted from the 4-figure table. And mantissa are decimal and they are positive. While the characteristics can be positive, can be 0, and can be negative. Let us now see how we extract mantissa. So in mantissa, when you are checking the number, take for instance 78.47, it is checked in form of significant figure. It is checked in form of significant figure. The first 2 significant figure under the third significant figure add the difference of fourth significant figure. We look at 2 things. The first 2, when when you look at it, the first two significant figures, we are talking about significant figure, irrespective of the point. 78 is the first two significant figures. Then we check 78, 78. Under the third, under 4, that is, check 78 under 4. In the 4-figure table, under logarithm, 78 under 4, are we there together? 8, 9, 4, 3. Difference, add difference, 7. So you go under difference, under the same 78, under 4. Then you go under difference. The difference of 7 here is 4. Then you add 4 plus 4. This will now be 7498 point. Then you will now come to your table and write 8947 because you have already decided for the characteristics, which is this. So if we go to the second one, we check number 2. Check 30 under 1. Add difference 3. So what is 30 under 1? 30 under 1 is 4786. 4786. Alright, 4.4786. Then add difference of 3. Then we go and check difference of 3 is 4. Then plus 4. We have 0.4097. Then we'll now come here and write 4790. When it comes to number 5, let's look at number 5 here. Number 5, we have the number 0.0007. Where is the first two significant figure in this place? The first two significant. Okay, before we move to number 5, let's check number 4. 0.508. So check 50 under 8. When you look at this, we have 3 digits. The fourth significant figure is 5. Then 0 here becomes a figure. When the 0 comes after a significant figure, the 0 becomes a figure. So we now have 3 digits, 508, because this one is not a figure, because it doesn't come, it comes before a significant figure. So it will not be 50 under 8. No difference, because there's no 4th digit. So 50 under 8, that is 7059.7059. So the answer to the fourth one will be 0.7059. Then when it comes to this, number 5, we now have 0.0007. How do we check this one? 0.007. So what we need to do here is to put, we have just one significant figure. And if we have one significant figure and we put 000 to it, it makes no effect if it is after point. If it is before point, we put a point here and slot in 30. We put a point and slot in 30, because when you have 7 and 7.00, it makes no difference. So hence, we now check 70 under 0. That is what we are going to check. What is 70 under 0? Is 8451. 8451. It will now be point. So this one will now be 8451. On this note, we have been able to see how we can use the four-figure table, especially logarithm, and how we can determine the characteristics and the mantissa. So in the next class, we are going to see how we can determine use the anti-logarithm table to decide on the final answer. Then we'll now see examples on how this can be used interchangeably, logarithm and anti-logarithm. Thank you very much.